Hey everyone, you're listening to the Simple Electronics Podcast. I'm your host, Dan from the Simple Electronics YouTube channel. This episode is brought to you by Patreons just like yourself. So go down to patreon.com/simpleelectronics to support the show. All right, so before we get started, my voice was getting better, but now it seems that it is not. And so I was planning on heading to the walk-in clinic. Don't have a family doctor because Ontario. I decided not to go because my voice was getting better. And now, as you can possibly hear, it is not. I have also quite a bit of personal updates, which I will put at the end of the show like I tend to. But please excuse the sort of jumping around and cutting that I need to do in order to record this podcast for you guys every 2 weeks. Okay, let's get into it. I'm going to try to project my voice a little bit less here, so I'm talking a little bit closer to the mic. Hopefully this works out good for my voice, my throat, whatever. So today I want to talk about circuits, and not just like circuits like circuits for circuit's sake. I mean like beginner type circuits. Now, I know that every time I come on here and talk to myself when I don't have a guest, I end up saying that I'm planning X, Y, and Z for a video or a video series or making a PCB or what have you. But what you have to keep in mind is that these podcasts for me are more like stream of consciousness. They're more about like what I'm thinking of, what's on my mind, and it's not anything polished. And I do realize that it does take me quite a while to make a video when I come up with a concept, because I suppose I overthink the delivery of that, the framing, as I was talking about last week. So I'm not going to promise that this is going to be a video or a video series coming up. However, I do want your opinions that when it does become a finished product, I want to know if you think it should be a video with a couple circuits, and then maybe another one with some more circuits, or if I should do a series with one video dedicated to each circuit. So the idea is, once someone has just gotten their starter kit, for example, peel the label off of it, there are a couple of circuits. I think I've managed to find like 7 or 8, something like that, maybe a little bit more, circuits that are very simple to put together, have very low parts count, but they do demonstrate something important about electronics, like a concept or something, or they're just fun to put together. And so the idea is, I'm going to talk about my ideas for what circuits fulfill that need, and then I shall, either make it into, a series or a video. And I do want your opinions on whether that should be, a series or a video. Most of these circuits are very simple, so they won't take very long. So a video on them would maybe be like 5 minutes. Some circuits are a little bit more in depth. There's more things happening. So that would be more of like a 10-minute video. However, it is possible to condense a whole bunch into a smaller thing. So let me just tell you my criteria, what makes a circuit beginner friendly. I would say it should only have one integrated circuit maximum, maybe 2, but I think 1 is a really good place to start. Don't forget, you and I, you listening and I probably have a little bit more comfort with building circuits. We've done it many times before, and if we fail, that's fine. We just, trace our problems. But someone who's learning electronics probably doesn't have the same level of patience or confidence that we do. So 1 IC probably is the maximum. So 1 IC, maybe 2, but 1 is my goal. And a handful of components, probably, less than 10. Less than 20 is pushing it, but less than 10 components is, I think, a good ask. Because don't forget, these kits don't often come with a lot of the same components. So if you wanted to build, let's say, a Knight Rider circuit, that might use all of the LEDs that you have available in a kit, for example. And the other thing is it should be low component cost, because you can argue that a Raspberry Pi can count as one component, but here in Canada, Raspberry Pi 4 is like $100. So that's not really good for beginners. Now, I'm not saying like a Raspberry Pi is something that someone brand new to electronics, component level electronics needs. I'm just saying if you need some sort of weird, germanium diode or something, probably not a good circuit. So I have a little bit of a list. I used, kind of like all of my brain resources to get this done. But don't forget, I do want your opinions if I missed anything in this list. So this is assuming that, people have their breadboard power supply, and unlimited wire, whether they cut them out of Ethernet cables or just have the breadboard jumpers, whatever it may be. So number one is a 555 timer A-stable LED flasher. So I don't think that the 555 timer circuits are the simplest to build. The way that the 555 timer is laid out, it means you do have to cross some wires over. There are multiple connections into the same pin. I think it's a little daunting to start with a 555 timer, in a stable mode. But I think if you eliminate the stuff like the bypass capacitors for stability, I think you can get the part count down enough. And I believe with an accompanying video or article with a, well laid out, like a fritzing type diagram, I think I think it's pretty good. So it's not something like a 6-year-old would be able to pick up right away. It's a little bit more complicated, but it's fairly simple. And honestly, if you want to learn electronics, you probably want a 555 timer circuit. And I put it on the very top of the list because the 555 timer aficionados are quite, let's just say, picky about, how they're portrayed. So the 555 timer aficionados need to be at the front of the list because they are special snowflakes. I feel you. I like the 555 too. I just think that it has so much fanfare for, maybe for good reason, but for beginners, it's a bit overwhelming. So yeah, I think if you, drop the decoupling cap, you're going to need what? The 555 timer itself, an LED with a dropper resistor. You need 2 resistors for a voltage divider. You need a capacitor for the charge and discharge to set the timing. I think that's it. Like, I think if you just cut all those unnecessary stuff out, stuff that doesn't matter because you're just building on a breadboard anyways, I think it's a relatively simple circuit with explanation. And the cool thing is you get to flash an LED, right? You get to use fully analog circuits to flash an LED. Plus, I think you can push the concept a little bit further, because if the beginner has access to an oscilloscope, you get to see the oscilloscope trace of the charge and discharge of the capacitor. It makes for a nice analog signal, but also shows you sort of like the time constants. Maybe not, calculating time constants are maybe a bit advanced for beginners, but it makes a really pretty display on the oscilloscope. So just think of someone trying to learn the circuit. They have a couple of probe points they can take a look. There's the output, and there's the charge and discharge pin, the threshold voltage. I don't remember what they're called. I have a giant 555 timer somewhere here that I put together, but it's not in iShot right now. So I think it's a decent first circuit on the list. Second thing, I think, going a little bit more simple, because don't forget, it could be overwhelming at times, is just an LED that is turned on by an LDR. So essentially, in my mind, you would just need an LDR, an LED, a dropper resistor, maybe a bias resistor, and a jelly bean transistor. I think pretty much all the electronics kits come with a couple of transistors, a couple of different kinds. But with just a jelly bean transistor, You pop the LDR onto the base, and then you can activate it by using a flashlight or your phone battery light, or you can make it oscillate by using the LED to feed back into the LDR. I think what's really cool too is that if you're really good with your shading, like if you're able to control the shadows and sort of hover your hand over the LDR at different heights depending on your lighting, I think you might be able to get the bias of the base just right, that you'll be able to actually change the brightness of the LED by how much light is touching the LDR. LDRs are fairly common as well, and I do believe most kits have LDRs in them. The only thing that's really bad about an LDR is it's a cadmium sulfate cell, right? However, I think it's also possible to use an LED as an LDR. So I guess at worst, you could just try to wire up an LED. I think you would need a MOSFET though, and not a transistor, because I don't think the LED will provide enough current. Although, I don't know, maybe if you set it up in a Darlington pair. We're getting a little bit more complicated now though. Next on my list is an LED activated by a MOSFET instead of a transistor. So just hear me out on this one. I mean, it's not super obvious why this is more interesting, but you just build a regular LED dropper resistor MOSFET circuit. But the thing is, you leave the gate connected to a wire, and then you can activate it by touching it. Like you can just hit it with your finger, and it'll charge the gate of the MOSFET enough to let current, through and light the LED. And then to shut it off, you can touch that wire and touch something grounded. So let's say the ground prong of an outlet or a big metal device or whatever, and you'll actually drain the capacitor in the gate of the MOSFET, and you'll turn off the LED. So I do this demo all the time with my students at the college when I used to teach, because it's really interesting to show how much more efficient a MOSFET is compared to a transistor. You need just a whiff of current to turn on the gate of a MOSFET. And before you guys jump down my throat, I know MOSFETs are activated by voltage, not current, but there is a tiny bit of gate leakage current. So you do need a little current, or else a MOSFET will eventually just shut itself off from the leakage. But so this is a really good thing for people learning electronics specifically, to understand that they need to tie the gate of their MOSFET either high or low, always, because or else it might end up in a floating state, especially if you have a microcontroller attached to it and nothing solidly driving the gate. You'll get some spurious things. And these things can actually be dangerous if you're building like dangerous circuits. Like if you're building some sort of motor control, for example, your motor can get started, while you're working on the damn thing, because the gate is not pulled high or low very solidly by a pull up or a pull down resistor. So I think it's a really cool demo that you can just grab, static electricity from essentially nowhere and turn on and off the gates of these MOSFETs. And I mean, for a beginner, if you look at it through their eyes, it's kind of magical, right? To see that you carry a charge and be able to light an LED with just touch. No touch IC, no capacitive, microcontroller input, nothing. Literally just the gate of a MOSFET. I think some kits do come with MOSFETs, but I'm at the point where I recommend getting a set like I think it's the 1N7000 or 2N7000. Extremely cheap MOSFET and worth a play. Next one up is the Joule Thief. So the Joule Thief, I don't remember. I think it was Julian Eilert. It's either Julian Eilert or Big Clive that coined the term Joule Thief. And back when I just started watching electronics YouTube, it was, Julian's and Big Clive's videos that I had stumbled upon, and they each build jewel thieves. And I thought this circuit was really cool, and I think it's a great project for beginners to give a shot. Now, you don't need very many components, right? You need a transistor, an LED, a resistor, but then you need a transformer, and I would highly recommend winding your own transformer. Beginners, I would recommend to them to do it themselves. Big Clive and Julian, in fact, have great videos on how to wind these transformers. You just start with a loop of wire, and you loop it through, then you cut the ends. Also, if you need to find, an inductor, you look no further than an LED bulb, or even better, a CFL bulb, like a compact fluorescent bulb. They have inductors inside of them that you can use. I did the exact same thing. This circuit is really cool to take a look at on an oscilloscope as well, seeing the voltage spike of the capacitor charging and discharging, and the coil creating the extra voltage. Really cool setup, and I think it's really satisfying too to grab a AA battery, or I should say a cell, or a AAA cell that you thought was completely depleted, right? Half a volt or less, and you hook it up to the circuit, and all of a sudden you're lighting an LED with a 2.7 volt forward voltage. Really cool device to build. If you have not seen Julian's and Big Clive's Jewel Thief videos, I would recommend you take a look. It was they were formative videos for when I was, thinking about making my own YouTube channel. But even before that, just messing around with electronics. Fantastic videos to watch. Go and take a look. Now, if you're just hearing this term for the first time, the Jewel Thief, it's not Jewel, it's Joule, which is incredible because a joule is a unit of charge, I believe. Is it an energy? It's like electric energy or something. Anyways, so Joule Thief, which is a fantastic name for the circuit because it literally goes into your depleted cell and sort of like sucks out those couple extra milliamp hours, microamp hours, or whatever it may be, all the way till it's completely depleted. Phenomenal circuit and lots of fun to build, and very satisfying when you build your own transformer for it. So that's really cool. So next is a LED chaser with a CD4017. I think the CD4017 is a decade counter or a shift register. I don't quite remember. But those CD4017s are included in a lot of electronics beginners kits. In fact, I will look on Amazon right now. Electronic starter kit. Now, this one is an Arduino kit, so it doesn't. Oh, I think it does come with it. No, 74HC959. That's not it. I can't really see in the image the other one because there's two ICs in this kit. Nope. Okay, so this one doesn't have it. Let's check another kit. There's another kit, and that one has a 74HC959. What is it, 74HC959? That's a shift register. I mean, it should work, right? Either way, this circuit is incredibly simple, but it is a very satisfying way to turn on something like 8 LEDs or 7 LEDs or whatever it may be. And usually this goes along with a 555 timer. So if you built your 555 timer circuit and you want to drive something with it, this circuit is a great idea, a great way to get all your LEDs to light sort of like in sequence. You only need one dropper resistor, so it's really all the LEDs in one resistor because the LEDs are only one at a time. But what's great is that you can actually put the clock input to like a push button. And I believe it was Julian Eilert that use like a micro switch to step through his circuits. And so even if you don't want to build a 555 timer circuit, you can still light these LEDs with just the use of a switch. And as you grow in your abilities and your confidence, then you can use your 555 timer to feed the clock and, step through. And then, you build your confidence even more. You put a smaller resistor, a smaller capacitor on the 555 timer to increase the frequency, and you can push it and see how far you can go, like how fast you can make it scroll through this. So I think it's a really cool circuit. And again, very satisfying way to light a whole bunch of LEDs. Next one is a bistable multi-vibrator. So actually, I made my first multi-vibrator, only a couple of years ago. I mean, aside from the ones you buy in kit form, I just built it on breadboard. And I don't remember why I was building it on breadboard. I think I needed some sort of oscillator, and I didn't feel like building a 555, or I don't remember what the deal was. But I built my first one not too long ago, and it's really satisfying. So essentially, it's like 2 transistors, 2 capacitors, and like 6 resistors and 2 LEDs. And the LEDs will turn on, in turn, simply because it is exploiting the fact that no 2 components can be exactly the same. As soon as you connect the bistable multivibrator, one of the resistors will have slightly lower value, or one of the capacitors will have slightly lower capacitance, and then one of the legs of this multivibrator will turn on first, and then just by nature of it being on, it will discharge, and then the next one will be on, and then it'll discharge, and so on and so on. So only a couple of components, but you can build the circuit to be very symmetrical looking, and it looks really good, and you get 2 LEDs that flash instead of the just one, and you could probably just short one of the LEDs if you wanted only one to go. But that is the coolest part, because this is all analog. It's literally a capacitor being charged via a resistor, and when the base of the transistor gets enough charge from that capacitor, it discharges, and the cycle will oscillate to the other leg, which will do the same thing, and then back and forth. Really cool circuit, very satisfying to put together as well. Next one that I had in mind was an H-bridge driver. Now this one is a bit more complicated. You need 4 transistors, but I actually made my own H-bridge driver on a PCBWay project, and it was very satisfying, especially the fact that you can just use regular jelly bean parts. Like you can literally buy 100 transistors, and you use 4 of them, and you can control a motor in 2 directions. So super simple. You only need 2 inputs to drive the H-bridge. And it also teaches you about like polarity control. So for example, you can feed current in one way, light an LED, feed current in the other way, and you light a different LED. Or you can have a motor turn clockwise, you feed it the other way, counterclockwise. You can use it to, run a vibration motor. You can use it to drive a speaker. You can use it to drive, a solenoid, power an electromagnet and change the polarity on it. Lots of things like that. You can even drive a transformer, and you get like an AC voltage out of the other side, because you can drive it positive on one sequence and negative on the other. And again, jelly bean parts, couple resistors, 4 transistors. I used like jelly bean 3904s and 27. Oh geez, I don't remember my part numbers anymore, but jelly bean parts. And in fact, just talking about this, I had a lot of fun building it, and I've always wanted, since I built that, I've always wanted to build like a really tiny one using discrete components still. Like I know you can get ICs that are H-bridge H-bridge controllers or H-bridge drivers, but I want to build like a, discrete one, as, smaller than a postage stamp, probably be able to fit, 3 of these circuits in a postage stamp. And then if you do double-sided, you could probably get, something like 6 or 8 full H-bridges just off of the size of a postage stamp, for example, because the transistors you can use, since they're jelly bean, they can be absolutely tiny. You'll only be limited to the amount of space you have to solder wires on to actually, control your driver. So again, really cool circuit. So those were my ideas. Let me know if you had any different ideas, if you liked my ideas, or if maybe there are some things that you found difficult or specifically easy about these kinds of circuits. And again, the idea is going to be to make this eventually into a video or video series, but that is not in the near future, considering how much I'm struggling with my voice. And speaking of struggling with my voice, I think we're just going to move on into the personal stuff. So all the electronics only listeners, you guys can, you can go whenever you want. So yeah, essentially, I am seeing now that this is very difficult to record this podcast. So I'm going to have to go and seek some medical attention. I did all sorts of like the telephone and online hoops, and they said I should go in person. But the day before I was going to go in person, my voice was feeling much better. So I decided to just keep working on it. And yeah, here we are now with my voice completely destroyed. So why haven't I been putting out videos then? Well, I'm not sure if I mentioned it on the last podcast, but my Volvo, the current one that I drive, the V50 with the manual transmission, the clutch line blew up. It broke apart. And what it was is there's a flexible line that links to the hard line that goes to the master cylinder. You need a flexible line because the engine and transmission move within the engine bay, and it's held together with one metal clip. That metal clip corroded, and just the pressure of the clutch just blew it apart. So while it was down and out, I ordered the part, had to come from Volvo, which was, 7 business days or something to get. It took a very long time. Even had to cross the city to go pick it up. I went back home and I fixed the car and brought it home. But in the meantime, while I was waiting for the parts, I decided I just can't live with the anxiety of the Volvo going, breaking down at any moment. And I mean, the breakdown is not a good thing, but it's not the end of the world. I can fix most things, but the parts may not be available. Like for this manual transmission V50, which was not available in the United States, only in Canada and then Europe. So that part is special order, and I had to put it in. If something like the clutch were to go, a clutch, this thing has a pretty special clutch. It has a slave cylinder built into the release bearing. So essentially what actuates the clutch, it's all built in. So if the clutch were to go, you'd want to replace that as well. And the clutch itself is very expensive, and the flywheel is sprung for smoother engagement. You basically don't feel the engine pulses as much. Everything is much smoother. But to replace the assembly, so that's flywheel, clutch disc, pressure plate, and slave cylinder, that's like 3,000 Canadian dollars just in parts, and that's not dealership parts. At the dealership, probably be like $4,000 or $5,000. And so I keep having this sort of stress looming over me that if it breaks down in a way that I can't afford to fix it, or if it breaks down in a way that I have to order parts like I did, it's just not good. I used to work really close to home. I used to, at a stretch, I can bicycle to work or I can walk to work. It'll just take me quite a bit longer, but I have solutions. Now with the being a mobile mechanic and with the college not renewing any contracts because they're shut down, I'm basically working, wherever the job takes me, the mobile mechanic job. And sometimes it's relatively close to home, but that's pretty rare. And it's actually not close enough to walk. It would probably take a couple hours to walk to the closest job site. The next closest job site is, you can add another hour of walking after that. And then another common job site is actually over in the next province over, essentially, which is Quebec. So you cannot walk there or bike there. In fact, there's no public transit even that will bring you to the Quebec job site. So I need a car to work. So I bought a car. I bought a 2014 Honda CR-V. It is not exactly my dream car. And the thing is, though, I got a decent deal on it. It's not perfect by any means, but, it's not a POS, which is good. It's not a piece of crap. It has high mileage, 272,000 kilometers. I don't know what that is in miles, 272 kilometers to miles. So that is 169,000 miles. Perfectly fine for a Honda. Essentially, it's got the 4-cylinder K-Series. It does burn oil. Those were known for that. It does have a bit of a rattle from the VTC solenoid draining, or the VTC actuator draining. That's a known issue on those cars, none of which will disable a car, which is good, as long as they keep it topped up. It has the 5-speed transmission instead of a CVT transmission in the newer CR-Vs. So the transmission is much more reliable, which is good. It's not super rusty, although it is starting to show its age for sure. It's a well-used car. It's just not a piece of crap. And so far, the only money I've had to put into it for the safety check was a set of wipers. So tomorrow, if you're listening to this on YouTube, it would be today for you, the release day. I have a appointment for the safety check. But yeah, this is way more money than I've ever spent on a car. I mean, it's not that bad. It's not a brand new car. I priced out a brand new RAV4, and that was $50,000 taxes in. It was like the XLE with premium package, because that's all they have available. Essentially, there's a big demand on Toyotas right now and Hondas. So it was like $50,000 essentially with taxes. This CR-V with taxes is just under $9,000 essentially. So I have been saving up for a while. I was thinking that eventually the Volvo would have to go, and that time is now. So I was kind of expecting this. It sucks to spend that much money. Yeah, it's probably just under $9,000. We'll see with the safety check, and then I'm going to buy fluids and stuff. So let's say $9,500 Canadian, which is far below the average cost for these cars here in Ottawa. So I made out pretty well. However, it's still a big chunk of change. So that's what I've been doing. I've been hunting for cars, looking at cars, bought a car. I've had to fix my Volvo. I had to cross town to get the parts. I had to still keep working during all this time. So that's why I haven't been making videos. I've also had to do the seasonal open of our pool here at the house, which our pump was seized. We had to buy a new pump. It's just, there was a lot of stuff on my plate. And now with the health issues, it's not like I can record a video easily anyways. I haven't live streamed, which is my favorite part of YouTube, for a very long time. So yeah, I'm struggling on that front. I want to get back into it. I can't right now. My voice is too unreliable, and it's taking me everything just to record, 30 minutes of podcast every 2 weeks. So I'm going to, dig down, try to reach out to people to come onto the show so I can save my voice essentially. But yeah, that's the deal for now. I do want to say though, after last episode, talking about the framing. There is a creator, fairly large creator, that I respect very much. That was actually a guest on the podcast, reached out to me and said some really kind words, and also commiserated with the fact that they had to do the framing as well. I don't want to call them out. I don't know if they want me to call them out, but I just want to say it was really nice hearing from a creator, which I don't expect at all for people, especially creators, to listen to the podcast, because it's kind of long and, it's not exactly their domain in this case. But I just wanted to say that it was really kind of them to reach out and commiserate. And they said some really nice things about me, my channel, and the podcast. So stuff like that is really good to hear. And because of people like that and people like you, I keep keeping on. So I got to let it go here because I need to rest my voice. And I've got a big day tomorrow. And of course, I've procrastinated the recording of this podcast way too long. I really should have done it over the course of 2-3 days, but I did it all in one day. And in fact, in the span of 4 or 5 hours. So I need to go rest. I need to edit this. I need to upload it. Thanks everyone for listening. I'll catch you in the next one.